Now that you hopefully feel more comfortable with interval notation, let's start using it to practice expressing different characteristics of different functions or graphs. In these next examples, we're going to be talking about finding domain and range. Remember, domain represents all of the x's on a graph, and that is from left to right. Range represents all the y's, and that is from low to high. On that far left example, domain, from left to right, you'll need to use the values that are on the x-axis. So our furthest left value is here. It has a closed circle, so it will get a bracket, and that is at -2 on the x-axis. Our domain ends right here at the open circle, which would imply a parentheses, and that's value is at +3. So the domain is -2 with a bracket, comma, +3 with a parentheses. All of the x's, the domain, is everything caught in between those two values. Now what's interesting is the y value, the range, in this particular example ends up being just one number. You don't have to actually show an interval. That would be the y values of -3. So there's a couple ways you could do this. If you really want to use interval notation, which it's not an interval, it's just one number, you would have a bracket around the number -3. That's the only number on the y. So is it a function? Yes. Is it a beautiful one? You're probably a little uncomfortable with it, honestly, just because it's only one number. Now, you could also have done this a different way. You could have done a set for set notation. So you could have put the range as the set of -3. Open set, -3, closed set. Just to show that it's not an interval, it's just the one number. We would accept either one of these. I'm probably more comfortable with this one because it's not an interval, and that's what I would probably choose to do, but we're not going to scoff at that. Either way. Let's go to the next example. Now, from left to right. So, remember, your domain is your x, your range is your y. We're looking from left to right and then from low to high. If you do left to right and low to high, respectively, for domain and range, you'll always have the correct number order because it'll be from least to greatest, which is how we always write all of our stuff anyway when we're talking about interval notation and etc. So from left to right, our far left point is here, and that looks to me to be at +1. So we have a bracket, +1 with a comma. Our far right point is an open circle here, and on the x-axis, that is at +4. So my domain for this graph is bracket 1, comma 4, parentheses. It's every x caught between 1 and 4. Not including the 4 because it's not closed, it's open, therefore it's the parentheses. I think you've already got it. Okay, so the range, low to high. So the lowest point is here. That is not at 4 when you're talking about the range. That is at -1 because range is y, low to high on the y. The highest point is here, and that is at +3 on the y with a bracket because it's a closed circle. Let's try the next one. This is going to be a little bit interesting. This graph is not a fabulous graph. I wish this graph was drawn a little bit differently. You could go either way. Okay, so domain, left to right on the x. The far leftmost point is here. That appears to be at, is that -4? it's negative 3, excuse me. So the domain, no question, has negative 3 with a parentheses for its far leftmost point. This is where things get a little weird. This graph is particularly difficult to understand in terms of, like, does that just keep going forever as we go down? Does it also go right? Or is it stopping and halting at 2? That's really kind of tough to understand how, like, and where the far rightmost point is going, because it looks like it's almost going vertical, but that's not normal behavior with functions. So we're going to go with what's normal behavior for functions. And even though this graph is kind of hard to decipher, we're going to say instead of it stopping at 2, as it goes down forever, it's also gradually, very slowly going right forever. And if it's going right forever, that means it's going to hit every x. That would be all the way to positive infinity on the x-axis. Now, if you want to argue that the graph stops at 2, then that would be what your interval would look like. But honestly, I'm not quite sure which one is correct on this one. I don't have enough information, which that's awesome. So for now, for argument's sake, we'll let it be. Okay, low to high on the y for the range. Now, the lowest point of this graph is that arrow again. Now there's no argument. It is definitely pointing down for forever. So from low to high, it is coming from negative infinity. So it's going to start from left to right as you write them in numerical order. The lowest value is negative infinity. The highest y value is not over here. It's here. Range is low to high on the y. That's the highest value. So our highest value is at positive 3 on the y. Since it does, in fact, touch positive 3, you get to put a bracket. Now, how do you know it touches positive 3? Well, the biggest takeaway is that there clearly is not an open circle like there, right there. If that were open, it would be obvious, so we get to assume it's closed. And of course, closed means put a bracket on it. Okay, the last example of domain and range. You have a union. You have two separate portions of graph on the same coordinate plane. In this graph, the domain and range will have two different things attached together through a union. As long as you go from left to right and low to high, you're not going to mess this up. So, far left to far right, first portion of graph. The first portion of graph I see with the far leftmost point is right here. And that is a closed circle at what appears to be negative 4. So I've got bracket negative 4. Now, the far rightmost portion of graph of that chunk of graph is there, the open circle at negative 1. So you'll have negative 1 with a parentheses. Then we put our union and continue on. The far leftmost portion of the second half of the graph is at positive 1 with a closed circle. So it is bracketed positive 1. And the far rightmost portion of the second half of this graph appears to be at positive 4 with a bracket. Again, all of those were closed, so brackets, not parentheses. The only one that was open is the one that got the parentheses at negative 1. Your range on this one is kind of a weird one again. You're still going to go low to high. The lowest point of this graph is here at negative 2. So we've got a bracket at negative 2 because it's closed. The highest portion of that chunk of graph is here at positive 1. And here's where it gets weird. Like the very first example, when you do the union, you only have one number to connect with the first interval. That number is going to be 3 from the graph because that's the y value for the other portion of graph. So you've got the choice of doing just the set of 3, or if you wanted to write it -2, comma 1, union. Again, you would do just one number. I know a portion of that has an open circle, but since there's only one number, even though you have a domain that has an open circle, the y values for every point on this portion of graph are all just one number, and that number is 3. And you definitely hit 3 for the y value for all of those. If you hit it, you include it, which is why we have brackets on that interval.